Hello to everyone. Let's quickly do this question on question number 2, which is on Newton's laws of motion. A 20 kg block, that is this 20 kg block, is resting on the rough surface, which means there is a friction there. It can be a kinetic friction or a static friction surface. It is connected to P and Q by a light inextensible string moving over a frictionless pulley. Q and P are glued together, having a combined mass M. A force of 35 newtons is now applied to 20 kg block at an angle of 40 to the horizontal, okay, as shown in the diagram. Now the first thing that we need to do is to draw the free body diagrams. So we have this is force applied here, then there is a surface here, which means we do have the normal force. So we have the normal force, the force that is exerted by the surface on an object in contact with it, and it acts perpendicular to the surface. Then there is a force in this string, so this force pulls 20 kg, we call it a tension force. Then we have the weight, obvious, that is Fg. This is our force diagram. Let's look at this one. In this one, there is a force that pulls this one upwards, which is a tension. Then we have Fg. So we have Fg, which pulls this system downwards, the Fg for this one. Okay, now they say the 20 kg block experiences a frictional force of 5 newtons, which means we do have the frictional force here, and it moves to the right. 20 kg moves to the right. What does that mean? If 20 kg moves to the right, meaning that the friction is going to the left, because the friction opposes the motion of an object. The friction goes to the left. Okay, at constant what speed? When they say the speed is constant, which means there is no change in what? In speed, meaning that the rate at which speed changes is equal to 0. Therefore, acceleration is equal to 0 because there is no change in speed. Okay, there is no change in velocity. If the acceleration is equal to 0, therefore the net force is equal to 0 newtons also. If we can extend to grade 12 work, the net work done is also equal to 0 joules because of that constant speed. Now let's go to the questions. The first question, define the term normal force. The second question, draw the labeled free body diagram, calculate the mass M. Then at a certain stage, the motion, the block Q breaks off and falls down. How will each of the following be affected when this happens? What will happen to your tension? What will happen to the velocity of 20 kgs? Okay, now let's draw the free body diagram. Let's just copy the free body diagrams that we have there. We have the force diagram, and now let's draw the free body diagram. Then for 20 kg block, we have the slanted force, which is force applied. We have the frictional force, and then we have Fg, then we have the normal force, then we have the tension. Then for MKG system, for MKG, we have only the tension, then we have Fg. Okay, then remember I said on the earlier video that when you see the slanted force, you must write the components of that slanted force, which means we have F applied to Y, then we have F applied X. Then you must remove the original force. So we're left with the components. This is our free body diagram for 20 kg block. Okay, this is our free body diagram for 20 kg block. So the first question here says define the normal force. The normal force is a perpendicular force exerted by the surface on an object in contact with it. Normal force is a perpendicular force exerted by the surface on an object in contact with it. Now if we can look here, the MKG object is not in contact with the surface here, which means there is no normal force and there is no frictional force. Then here there is a surface, which is the table, and the object is in contact with what? With the table, meaning that there is a normal force, there is a frictional force. Okay, now the second question here says draw the free body diagram for 20 kg block. So this question is 2,2. That is the free body diagram for 20 kg block. The third question says calculate the combined mass. The combined mass. So there is no specific formula for mass, but the mass that we are talking about is mkg, which is here. This one is equal to mg, which means we need to know this gravitational force. Then we get the mass. So the focus is on this gravitational force. How to get this gravitational force? We can get this gravitational force by using F net is equal to ma. Okay, the acceleration is equal to 0. Therefore, the net force is equal to 0. Okay, so the net force now, the net force here is Fg and a tension. Now we have to decide which one must be positive and which one must be negative. Now, if we say the object is moving to the system is moving to the right, meaning that it is moving in this direction. Therefore, this one must be positive, this one must be negative. Friction is negative. Okay, so the tension in this one must be negative. So we have Fg, which is positive, minus the tension, which is equal to 0. But we do not have the tension. Okay, which means we need to go to the 20 kg block, right? All right. Then here Fg is equal to mg. So from here to here, Fg is equal to mg minus the tension, which is equal to 0. Okay, so the mass of this one is m, but g is 9.8. So m is g 9.8 minus the tension, which is equal to 0. Okay, so we have this equation. This is our first equation. We have two unknowns, that is the mass and the tension. Let's go to this one, and see what we'll get here. Here we're going to use the forces that do work on an object, the forces that move an object to move, because these ones are perpendicular. Okay, meaning that we have this tension, and this tension must be positive because it goes to the right, and this one must be negative, meaning that F net, which is equal to 0, F net which is equal to 0, then the F net will be made by tension minus Fx minus Fk, which is equal to 0. Okay, then after that we substitute. We do not have the tension. Okay, we do not have the tension, but we can calculate Fx. So the tension minus Fx, we said it's a force cos theta minus Fk, which is equal to 0. I don't know what is happening here. Then let's substitute. The force that was applied was 35 at 40 degrees. So this is 35 at 40 degrees. So we have the force that is applied tension minus 35 cos the angle is 40 degrees minus the friction was given as 5 newtons. The friction was given as 5 newtons. So we have 5 newtons, which is equal to 0. Now here we can solve the tension. Then you press the calculator here, then we get the tension. The tension is equal to, let me press the 31,81 newtons. This is the tension. Now let's go to the first equation. The first equation is, if I can copy it, that is the first equation. The first equation is m, or it's 9.8 times m minus t, which is equal to 0. Then let's substitute. The tension is 31,81. So it's 9,8 meters minus 31,81. That is the tension, which is equal to 0. Then we transpose this one. We have 9.8 meters, which is equal to this one. When it goes to that side, it's positive 31,81. Okay, then let's continue. Then we divide by 9.8 both sides. So the mass now is equal to 3,25 kgs. So that question is answered. That is the mass that we're looking for. Then the following question says, at certain stage of the motion, block Q breaks off and falls down. How will each of the following be affected when this happens? What will happen with the tension? Let's go to the free body diagram. Now, if we can look at this free body diagram, this free body diagram has the mass which combines P and Q. Now, if Q is not there, meaning that the mass will be less than expected, meaning that Fg will decrease. When Fg decreases, remember this object is going down here, meaning that Fnet of this object is directed down, which means depends on Fg. So if you remove Q, Fg will decrease. When Fg decreases, remember our net force can be Fg. When this one decreases, when the forward force decreases, what will happen to this one? This one will decrease because the weight decreases. Okay, since the weight is decreasing here, this one will decrease. Remember we said Fnet, I don't know what is happening. Let's draw the free body diagram here. We have the tension, we have Fg. Now Fg decreases. Okay, Fg decreases. Remember we said Fnet is equal to MA, and Fnet is equal to 0 in this case, meaning that if you substitute here, your tension is exactly equal to Fg in this case. Now Fg decreases. If Fg decreases, to make this net force be equal to 0, also tension will decrease, which means the answer there is decreases. The tension decreases. So we'll choose to decrease here. Okay. Then let's come to the velocity. What will happen to the velocity now that if Q is decreased, but if Q is removed, then what will happen to the velocity? Okay. If now you decrease Fg, if you decrease this one, if the downward force decreases this one, net force what? Decreases, because the net force will decrease. So if the question says what will happen to the speed now, so now that we say this one decreases, since we say the net force decreases, which means the velocity or speed decreases also. Okay, the speed will decrease. So the answer is decrease because the net force decreases, or the acceleration decreases. So you get 2 marks for saying the net force decreases, then you get 1 mark for choosing decrease for the velocity. Then we are done. Thank you very much. Thank you.